Hello, folks, and welcome to the next video. In the last video, we would have learned about some special types of lines called tangents. And as a quick reminder, a tangent is a line that touches the circumference of a circle at exactly one spot. So today, we're going to learn about another type of line that's called a chord. And what a chord is a line that will touch a circle in two places. Um, and there's one kind of specific property that we're going to talk about when it comes to chords, and that property has to do with what's called perpendicular bisectors. So to understand what a perpendicular bisector is, it's useful to know what those two words mean. So the word perpendicular means 90 degrees, a right angle. So if I'm looking at this shape here, the symbol down here, this little square, is telling me that this line, this blue line, is perpendicular to my black line here. Okay, and then the word bisector. So if we think about the prefix bi here means two, so two sectors, or to cut something equally in half. Right, so a perpendicular bisector is a line that cuts something equally in half, and it does so at 90 degrees. Okay, so why do we care? Well, this is the property. This is what's new. And there's three properties that we're going to talk about. Realistically, they're all the same property. But what happens is if two of the requirements happen, then the third one has to be true. So in this case, so if we read this line here, property number one says a perpendicular line drawn from the center of a circle to a chord bisects the chord. Okay, so if I have a line that starts at the center and hits my chord at 90 degrees, it will always cut that chord into two equal sections. Okay, so that's property number one, right? Line from center, 90 degrees, two equal sections. Property number two, a perpendicular bisector drawn to a chord will pass through the center. So again, you'll notice we have the same words happening here. We have a perpendicular and bisector and center. So in this case, the two prerequisites are that we have a perpendicular or a right angle, and we're being told that it's bisector. So this line will pass through the center of my circle. And then finally, number three, if a line passes through the center of my circle and it bisects my chord, then it will always do so at a 90 degrees, right? So it's the same three pieces of information each time, right? Same thing. Passes through the center, midpoint or bisects, right? So another word here would be to think about as it bisects. And then if it meets those two requirements, then the line has to be perpendicular. Okay, so that's the other property of lines and circles that we're really going to focus on for this unit. So let's just look at a couple of example questions that might come into play. But just quickly before we do, one thing I want you to consider is there's one other thing that we got to be aware of that we already know, but we just have to recall is that if I have a isosceles triangle, meaning that two of the side lengths are the same length, then the two angles will also be the same size. And where does that come into play? Well, that comes into play in an example like this circle here, where I have one radii, right? So it goes from the center to the edge of my circle, and then I have a second radii. And what we know about radii in a circle are that they will always be the same length. So what that means is if I add a third line or a chord where those two radii touch my circumference, that's going to always make us a isosceles triangle. So keep that in mind as we're doing some of these questions, okay? So here we go. Here's question number one. So what we want to do is we want to find these missing angles. We have angle Y and angle X. And again, we're going to use some of these properties that we know. So let's think about the property that I just said that we should already be aware of is that isosceles triangles will have two equal sides and two equal angles. So when I'm doing these questions, I'm always looking for the radius. Where is the radius? So from center O to point A, we have a radius. And from center O to point B, we have a radius. And what you'll notice is that those two lengths are the same, which means that by attaching A to B, I get a chord that makes that third side of that isosceles triangle. So if this angle at A is 33 degrees, then angle X also has to be 33 degrees. Great. Okay, and now we're going to look at some of those other properties we talked about initially. So what do we have here? We have a line that passes through my center. and it hits my chord. Where it does so, we're being told that this side length from A to C and this side length from B to C are the same length. So what that means is that this line is passing through my chord at the middle, or in other words, it's bisecting it. So passes through the center, passes through the middle. What do we know about this angle? It has to be 90 degrees. So finally, if I'm looking at this smaller triangle AOC, right? We know that one of the angles is 33 degrees, and we know that one of the angles is 90 degrees, and we know that the three angles inside of a right angle triangle have to add up to give us 180. So if I take 180 and I subtract 33 and I subtract 90, I'm going to get 57 degrees. And there we go. There's my angle Y. All right, let's try another one. So here we're being told that point O, again, is the center of the circle. And you'll notice that that happens a lot where point O ends up being the center of these circles. AB is a diameter, and it has a length of 26 centimeters. Now, we haven't talked about diameters and how that might come into play. But again, just be aware that we can always draw out other information. If we're given something, we might actually be given something else, just not kind of explicitly told that. So let's just keep that in mind for a second. CD is a chord, and it's 10 centimeters from the center of the circle. So to go from O to this point E, we're being told that this distance here is 10 centimeters. And then finally, what is the length of chord CD? So what we want to do here is we want to use those properties, right? Use those things that we already know to be true. So because this passes through the center of my circle, right? This line OE, and we know that this angle here is 90, which means that it's perpendicular to the chord. We also, from that, know that this thing bisects my chord, which means that CE is going to be the same length as CD. Now, that by itself doesn't necessarily help us, but what we can do is we can use this right angle because we know how to work with right angle triangles. We know that if I have a right angle triangle, then the Pythagorean theorem is going to work. Great. So how do I use that? Well, what is the length of the line OD? Or in other words, to figure that out, what is line OD? And if we're kind of thinking about it, we should see that line OD is actually a radius. Awesome. So if OD is the radius, well, one radius is half of the diameter. So that means that this line here has to be 13 centimeters. From that, I can find the distance from E to D by using Pythagorean theorem, right? 13 squared minus 10 squared is going to be equal to my side length ED squared, right? So then if I'm kind of just going through, we can grab our calculator and do some quick math here. So we get 169 minus 100. And then we take the square root of that, and we get 8.3 centimeters. Now, again, be careful because that is not our final answer. We're being asked to find the distance from C to D. This is the distance from E to D. But again, because this is a chord that's being bisected, what we need to do now is to take that 8.3 and simply just times it by 2 because it's the half, right? So we are going to get 16.6 centimeters. And there we go. Okay, so maybe take a second to pause the video, read this question, try it yourself, and once you're ready, start the video back up and check your answer. Okay, so here we go. A pedestrian underpass is constructed beneath a roadway using a cylindrical pipe with radius 1.8 meters. The bottom of the pipe will be filled and paved. The headroom at the center of the pipe is 2.8 meters. How wide is the pipe? Okay, lots of stuff happening. It's not an easy question, not going to suggest that it is. But if you stop and you start filling in some of the information that maybe not exactly given to you in the question, but can be inferred by what you know. So things like, well, I know that the radius is 1.8, which means that I know the diameter is twice that, right? So 1.8 times 2 is 3.6. Okay, so that's helpful. Why is that helpful? Well, now, if I were to take this line right here, this 2.8, and extend it, I know that this whole thing has to be 3.6. So if I wanted to find the length of just this missing part here, Okay, well now I can say, great, 3.6 minus 2.8 is 0.8. So this line right here is 0.8. All right, so again, you might be asking yourself, well, again, why does that matter? Well, the reason that matters is because with a lot of these questions, we're usually doing the same thing over and over and over again. And the same thing we're doing here is making that right angle triangle, right? I'm adding that radius that I know is 1.8 meters. And because this is right in the center of the circle, we know that this thing bisects my walkway here, which means that it's going to be 90 degrees. Okay. Well, I also have a radius from the center of the circle all the way down to the bottom of the pipe, but that's not the one I'm looking for. I want to stop it right here where my radius hits my cement. So in order to do that, I can take this 0.8 that I already know, and I can take it away from the 1.8 that we know the radius is supposed to be, and I see that the distance from the center of my pipe to my walkway is 1 meter. Perfect. So just like with the last question, what do I do with that now? Now I use my Pythagorean theorem and I solve for my missing dimension here. And then I'll times it by 2 in order to get the width of my walkway. So 1.8 squared minus 1 squared is equal to my missing dimension squared. So let's do that. So we get 1.8 squared, and we're going to minus 1 because that's 1 squared. And we get the square of that dimension is equal to 2.24, right? And then we're going to square root that, and we get that missing dimension right here is equal to 1.5. And then in order to find the whole width of my walkway, again, what we have to do with that 1.5 is we have to times it by 2, and we see that our walkway is 3 meters. Okay, so hopefully you followed along with that question because that would probably be one of the more challenging questions in this unit. So if you got 3 meters, awesome, you're exactly where you need to be. If not, make sure you're doing lots of practice and you're getting help and asking questions. All right, well, I'll see you all in the next video.